Inka?
Molarity, normality, ఇవన్నీ కూడా కాన్సంట్రేషన్ వస్తుంది.
Yes. Molarity, normality. Now then the next question is what it means by a solution.
Solute plus
Solute
solvent.
plus solvent.
Solute plus solvent is nothing but a solution. Okay. Now what is a solute and what it means by a solvent?
Lesser proportion is called solute, and the larger proportion is called solvent. Combination of solute and solvent becomes a solution.
Okay. Now I added 1 spoonful of sand into a glass of water, and I've added 1 spoonful of salt into a glass of water. Now, which one is a solution?
Salt and water, no?
Why not sand and water?
It can't dissolve, no, ma'am.
It will not dissolve. So what are solutions?
Homogeneous
They are
and heterogeneous
homogeneous
solutions.
mixtures of solute and solvent. Okay, and hence is the discussion. Em cheptunnanu ante, see, by this time we have understood that if there are dissolved salts present in water, it is just like any salt solution. The salt solution can be sodium chloride solution, okay, like the seawater, where the pH is mild alkaline, and hence it is a solution of NaCl in water. It's not obviously pure water. So whenever I'm expressing that, whether it is hardness of water or alkalinity of water, I'm talking about aqueous solutions. Correct? What are aqueous solutions? The solutions in which water is the solvent are called aqueous solution. So when I'm talking about aqueous solutions, it can be an alkaline solution, okay, or it can be hardness causing solution. In either of the cases, okay, I need to express its concentration, okay, and the concentration terms which are used to express water, okay, hardness or alkalinity are ppms, milligrams per liter, degree Clark and degree French. Okay, so these are the concentration terms that are used to express a hardness or alkalinity of water, or the concentration of the solutions that are available naturally, particularly in terms of the water. Okay, but before I start explaining you all that, I need to tell you about one more important technical term called as calcium carbonate equivalence calculation, which is called as degree of hardness. Okay, the next term which I need to tell you is expression of degree of hardness. Oh my God, it's better I write in a book. I don't know what to do with this. Not even the solution. I think I have written it with permanent. How to remove this permanent marker? Okay, let me not waste my time. By tomorrow morning, I clean it away. But I'll explain right now with you about the degree of hardness. No, I want to tell you like this. Okay, what I have done is, okay, because you are all now grown ups, you went out for a shopping. Okay, you went out for a shopping, and what you have done is you purchased lot of stuff, what all you wanted for clothes shopping, for example. Probably you might have bought in many things like your trousers, your tops, your shirts, and various other things. Okay, and after going home, you wanted to give the entire bill to your parents. Okay, your parents asked, you bought so many clothes and all. Now would you tell me what is the amount you have individually spent, and give me the entire bill. Okay, then what you are going to do, you tell me. You'll take the total amount of money that you have spent. You'll tell the what is the remaining money or you have kept, and you'll quickly show the bills of the various items you have purchased. Okay, so the total money spent, okay, is the entire expenses you have done. Okay, and what individual expenses you have given are the subdivisions of that main total amount you spent. Okay, just like that, in water there are different salts that are present dissolved. Like when you're taking a hard water, it might contain calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate, calcium fluoride, etc. So many salts are present dissolved in it, and all the salts are contributing to hardness of water. So when I'm saying this is the total amount of salt that is present in a particular sample of water, I am giving you a quantity called as total hardness. Okay, which is again sum total of temporary hardness causing salts and permanent hardness causing salts. Okay, now if I want to visualize all that, okay, then one important point I need to tell you all is that there is a salt called as calcium carbonate salt. Okay, so this calcium carbonate is one salt which always supports hardness of water, but is insoluble in cold water. Okay, the sludge whatever you're seeing on the vessel is because of this calcium carbonate that separates out when you're boiling water. Okay, so what is this? If this salt is insoluble in cold water, how would you say that it contributes to hardness? This is one salt always is associated with water, causing hardness because um, it quickly gets deposited wherever this water flow is there. Okay, always associated with water, but insoluble in cold water, but soluble in hot water under pressure, and hence is very important salt to be studied. What is calcium carbonate called in our native language? Sunnam rai.
Lime.
కాల్షియం హైడ్రాక్సైడ్ అంటే సున్నం, కాల్షియం కార్బోనేట్ అంటే సున్నం రాయి. ఓకే, అది తెలుసు. If you go out where there is always flow of water in the natural habitats, okay, వైట్ కలర్ ప్యాచెస్ ఏవైతే మనకు కనిపిస్తూ ఉంటాయో డ్రాప్ వాటర్ పడినప్పుడు ఆ వైట్ కలర్ అంతా ఏంటది? కాల్షియం కార్బోనేట్. సున్నం రాయనా ఏమంటారు తెలుగు? సున్నం రాయి. Okay, so adi discussion. So why I'm talking about this calcium carbonate? Now if I want to express degree of hardness, then I'll use the term called as calcium carbonate equivalents. Now what are these calcium carbonate equivalents? These are the technical terms that are used to calculate the amount of hardness that is present in water with respect to each single salt. Okay. Now, how to understand this? A few might be thinking, what is this, madam? Once she said big, and suddenly she is telling me that there is hardness of water, and she took me to rocks and she said, and wherever there is white drops, water drops falling, there are white deposits, which is called calcium carbonate. And then she's telling me all about the expression of hardness of water. And suddenly again she brought me to this world of expressing the hardness of water in terms of units like ppms, milligrams per liter and all. What is this all hell confusion? What I'm trying to tell you all is that because I'm talking about the dissolved salts present in water, okay, Just like I'll express the concentration of NaCl solution, HCl solution, NaOH solution. Because these salts are dissolved in water, I need to express the concentration. Okay. But generally, whenever we are preparing solutions, the concentration terms of are generally molarity, normality, mole fraction, okay, even milligrams per liter, etc. Okay, are all the concentration terms which we are generally using. We can also use this to express the concentration of that hard water or alkaline water, but that is not generally done internationally. Okay, IUPAC gives milligrams per liter, ppms, degree Clark and degree French preferentially as the units of hardness rather than the other unit, general units, concentration units like normality, molarity. Okay, so this part is clear. అర్థమైపోయింది. ఓకే, సాల్ట్స్ డిజాల్వ్ అయి ఉన్నాయి వాటర్ లో కాబట్టి ఒక సొల్యూషన్ అది. సీ వాటర్ కూడా ఒక సొల్యూషనే కాబట్టి దాని ఆల్కలైనిటీని క్యాలిక్యులేట్ చేయడం ఎలాగా అనేది ఒకటి. ఇంకోటి, నువ్వు గ్రౌండ్ వాటర్ లోంచి బోర్ వేసి నీళ్లు ట్యాప్ చేస్తే ఆ వచ్చిన గ్రౌండ్ వాటర్ హార్డ్ వాటర్ అని మనకు తెలుసు కాబట్టి దాంట్లో కూడా కాల్షియం మెగ్నీషియం సాల్ట్స్ డిజాల్వ్ అయి ఉన్నాయని తెలుసు కాబట్టి అది కూడా ఒక అక్వస్ సొల్యూషన్ అని నీకు తెలుసు కాబట్టి దాని సొల్యూషన్ కాన్సన్ట్రేషన్ ఎక్స్ప్రెస్ చేస్తామని ప్రయత్నిస్తే అప్పుడు ఏంటి యూనిట్స్ ఆఫ్ హార్డ్నెస్ వాడతారు? ppms, మిలీగ్రామ్స్ పర్ లీటర్, డిగ్రీ క్లార్క్, డిగ్రీ ఫ్రెంచ్. ఓకే, ఈ టర్మ్స్ వాడతారు. అంటే నువ్వు అక్వస్ సొల్యూషన్స్ సింథటిక్ గా ప్రిపేర్ చేసినప్పుడు నార్మాలిటీ, మొలారిటీ అనే టర్మ్స్ ఎక్కువ ఫ్రీక్వెంట్ గా అవి వాడతాము. కానీ న్యాచురల్ హ్యాబిటాట్స్ నుంచి అంటే సీ వాటర్ ని కానీ గ్రౌండ్ వాటర్ ని కానీ ట్యాప్ చేసి దాని హార్డ్నెస్ కానీ ఆల్కలైనిటీని కానీ నువ్వు డిఫైన్ చేయాలి అనుకుని వాటర్ కాన్సన్ట్రేషన్ ఎక్స్ప్రెస్ చేసేటప్పుడు జనరల్ గా ppms, మిలీగ్రామ్స్ పర్ లీటర్, డిగ్రీ క్లార్క్, డిగ్రీ ఫ్రెంచ్ కింద ఎక్స్ప్రెస్ చేస్తారు. సరే, ఓకే, ఫైన్. సో ఇప్పుడు కాన్సన్ట్రేషన్ టర్మ్స్ గురించి నేను డిస్కస్ చేయాలి. కాన్సన్ట్రేషన్ టర్మ్స్ గురించి డిస్కస్ చేసే ముందర ఒక ఇంపార్టెంట్ టెక్నికల్ టర్మ్ నేర్చుకోవాలి. ఏంటంటే అది ఎక్స్ప్రెషన్ ఆఫ్ డిగ్రీ ఆఫ్ హార్డ్నెస్ అండ్ ఇన్ టర్మ్స్ ఆఫ్ కాల్షియం కార్బోనేట్ ఈక్వివాలెన్స్. ఓ, వాట్ ఈస్ దిస్? అంటే calcium carbonate is one salt which is insoluble in cold water and also hot water, but it is soluble in hot water under pressure. Okay, high temperature and pressure makes this calcium carbonate salt soluble in water. Otherwise, this salt is insoluble in water. Okay, when this salt is insoluble in water, so why I need to break my head behind it? It's not like that. It's always associated with water. Okay, it's a common thing in our houses that when we make that pan and all, when we go out have pan, they'll apply that calcium carbonate over the calcium hydroxide. They put it on the leaf, beetle leaf. Okay, so it's the murky color, white color solution. What you are seeing is it's a highly concentrated solution. What you would realize, a normal naturally flowing water, if it is hard or alkaline, this calcium carbonate is always associated, making the water that murky. It will not be crystal clear. It neither dissolves nor it is devoid of it. It is always associated with it. But what is the beauty of it? Once if you do small filtration technique, this salt gets precipitated. Just like the white color sludge that gets deposited on the vessel when once you boil the water. What is happening? The calcium carbonate that was associated with that hard water was deposited along with the calcium bicarbonate decomposing into calcium carbonate. So what will happen? When once you rigorously boil and leave the water, it slowly gets percolated to the bottom of the vessel or the container. So it is not present in water right now. So what you can do is, in the in labs, what they do, they will just quickly filter that water, get the calcium carbonate precipitate out, and they calculate the amount of calcium carbonate that was associated with water. Why? for technical reasons. Okay. So in course of time, what they started doing is that they made equivalents of that calcium carbonate with respect to every other salt, and they gave a formula for calculation of the degree of hardness. Okay, this is to express this, like I was like trying to tell you the shopping experience. Okay, if that is not very clear to you, you went to a shop, a vegetable shop, then you asked that vendor to give 1 kg onions. Okay, then what that vendor does, quickly he'll put a 1 kg weight on left hand pan, and he quickly starts adding the onions on the right hand pan. Okay, common experience for us. That means that 1 kg weight, when once now removed, the onion weight will also be equal to 1 kg. Okay, now okay, if you want, you can keep that 1 kg onions on the left hand pan, and you can keep on adding different other uh, vegetables till the weight becomes 1 kg. Okay, so initially that 1 kg weight was the standard. Okay, when as soon as you weigh that 1 kg onions on the right hand pan, now can you put the that 1 kg weight of onions on the left hand side? Yes, I can put. Now can I measure one more 1 kg brinjals or potatoes on the right hand side? Yes, correct. So it is the same thing. What they do, they'll take the calcium carbonate salt out of the water. Okay, and they'll weigh that amount of calcium carbonate on the right hand pan. After that, they'll remove the weight away from the left hand pan and put the amount of calcium carbonate on the left hand pan. Okay, now I'll use that as the weight to calculate the weight of other salts with its respect. And this type of measuring is called as calcium carbonate equivalent calculation. Okay, and it is expressed as degree of hardness. Okay, what it is called? Degree of hardness. If you don't understand, you should raise your hand. Okay, I am very sure you might have got really confused, but you write this so that I can really make you understand it little differently. Okay, so next heading I'll have to tell you is about what is called as degree of hardness. Okay, degree of hardness. Please tell me, is the paper clear? Is my handwriting clear to you all? Hello kids. The session
Yes,
tarvata
ma'am.
nikar
Yes, ma'am.
please. Okay. Degree of hardness is the heading. First write this. Then you will understand what I'm trying to tell. Okay. Then you put a column like this and write calculation. This is very, very important. We will be doing numericals on this right now. Okay. Calculation of calcium carbonate equivalence. Is the subject of discussion. Now, did you understand the point about the calcium carbonate? Okay, I'll tell everything of this. Okay, but first point you need to understand, because probably might have got confused. I want to tell like this. Now, calcium carbonate is hardness causing salt. Okay, hardness causing salt is the first point. Clear? Calcium carbonate is equal to hardness causing salt. Okay, now what is the differential solubility it shows? Is equal to insoluble in cold water. Insoluble, BLE, insoluble in cold water, insoluble in cold water. Okay, so I'm talking about the differential solubility, insoluble in cold water. Okay, now when in which water it is soluble? Soluble in hot water, soluble in hot water under pressure. Okay, soluble in hot water under pressure. That's the next point. Okay, so this is the point. So when it is insoluble in cold water and it is soluble in hot water, why I should think about it? I need to think about it because it is always present in water, always present in water. As insoluble salt. అంటే ఏంటి? మట్టి నీళ్ళు ఉంటాయి కదా, ఆ మట్టి క్లే వాటర్ లో డిజాల్వ్ అయిందా? అవ్వలేదు, కానీ ఆ మట్టి నీళ్ళలో ఎప్పుడు మట్టి ఉంటుంది. సో అలాగే దిస్ కాల్షియం కార్బోనేట్ సాల్ట్ ఈస్ ఆల్వేస్ ప్రెసెంట్ associated with water. It is always present associated with water, just like the clay water. It is always present associated with water. Okay, and this is the point. What is the other important star mark point you should know is its molecular weight is 100. Its molecular weight is 100. Okay, and what you need to always remember here is, next point is that its molecular weight is 100 and this salt can be filtered. This salt can be filtered. This salt can be filtered. Can be filtered, dried, and weighed. This salt can be filtered, dried, and weighed. Okay, that's the speciality of calcium carbonate.
Dried and
Weighed. Okay, now slowly understand the topic. So what I'm telling you all, I'm telling you all about a technical term called as degree of hardness. Okay, calculation of degree of hardness in terms of calcium carbonate equivalence. First you start understanding this, don't think about anything else. Okay, I'm talking about this salt called as calcium carbonate. Okay, what is this calcium carbonate salt? It is hardness causing salt, which is insoluble in cold water but soluble in hot water under friction. Okay, one more thing we should know about this salt is that it is always present associated with water. Just like clay water, this calcium carbonate water is always very, very important. Okay, next, what's the other thing you should know about this salt is its molecular weight is 100 and this salt can be filtered, dried, and weighed. That's the easiest thing about this salt. Okay, so after understanding about this calcium carbonate salt, I need to understand one more technical term, that is calculation of calcium carbonate equivalence. Okay, so what does that mean, calculation of calcium carbonate equivalence? Okay, now This calcium carbonate is a salt which I have told you can be filtered, dried, and weighed. So what I have done, I took a 1 liter water in a vessel, and I started boiling that water to 500 ml, half liter. Okay. Now the question is, which type of salts are removed? Temporary hardness causing salts are removed. Okay, and they form what as they come out as sludge. Okay, so what you will see at the end of the boiling and cooling, you'll find a white color powder at the bottom of the vessel. Okay, so what the chemist will do, they'll slowly filter away the entire water. Okay, and they'll take out the sludge from that vessel. Okay, after getting that sludge from the vessel, they'll analyze what might be the composition. They will realize that it contains calcium carbonate and magnesium bicarbonate, magnesium hydroxide. Okay, so what they found that was that sludge which I got from the boiling of hard water contained calcium carbonate and magnesium hydroxide. Fine. Now, after that, what did they do? They slowly uh, dried that and they weighed it. Okay, and they claimed that sludge, which contained a combination of calcium carbonate and magnesium hydroxide, are the products of calcium bicarbonate and magnesium bicarbonate, which were present dissolved in that hard water sample. Okay, then they got one idea. We always recollect that calcium carbonate is always present associated with water. Okay, and it always imparts hardness to water. So why not I just give calcium carbonate as a salt for the measurement? Okay, just like I've told you, I've gone to buy few vegetables. On the left hand pan of the weighing machine, there was 1 kg weight. And I asked that vendor to give me 1 kg onions. So quickly what that vendor did, he added onions onto the right hand pan and he weighed exactly 1 kg onions. Okay. Now after going home, I realized I need to weigh some 1 kg of some other vegetable. Then on the weighing machine, can I put this 1 kg onions on the left hand side? Yes. Okay, because I know that they are 1 kg onions. I can put those onions on the left hand pan and I can measure 1 kg of any other vegetable I want. Okay, just like that, I'll I'll take the calcium carbonate salt that is present in a sample of water. Okay, and I assign the hardness of all other salts in terms of this calcium carbonate. Why this calcium carbonate is taken? For all these reasons. Mainly, molecular weight is 100. Therefore, the calculations are very, very easy when I'm considering this salt for calculation of degree of hardness. Okay, that's the idea. Hope you understood this concept. Okay, now, right, the formula used to calculate calcium carbonate equivalence. Okay, what's the next heading? Formulae used for calculation of degree of hardness. Calculation of degree of hardness. Formula used for the calculation of degree of hardness. Okay, it's an important one. Put a star mark. Okay, what's the first formula? Degree of hardness. Degree of hardness of salt. Degree of hardness is equal to weight of the hardness causing salt, weight of the hardness causing salt, weight of the hardness causing salt in milligrams, in milligrams, weight of the hardness causing salt in milligrams divided by equivalent weight of the salt, equivalent weight of the salt divided by equivalent weight of the salt into 50, into 50. Okay, is the formula clear to all of you? Degree of hardness of the salt is equal to weight of the hardness causing salt in milligrams divided by equivalent weight of the salt into 50. This is formula 1. This is formula 1. Now I have one question.
I'm unmute. No sound, ma'am.